Hello students, welcome to the lecture number 12 of chapter 6. In lecture number 11, we have discussed the theorem number 6.2. According to the theorem number 6.2, if a transversal line intersects any two parallel lines at two distinct points, then the two pair of alternate interior angles formed are equal. Understood? So what we have studied? We have studied if there are two parallel lines and there is a transversal line which intersect these two lines at two distinct points, then the pair of alternate interior angles are equal. It means this angle and this angle are equal, as well as this angle and this angle are equal. Okay, so this is the theorem number 6.2. As well as in the axiom 6.3, we have discussed that if a transversal line intersects any two parallel lines, then the corresponding angles formed are equal. As there are four pair of corresponding angles, so all the corresponding angles are equal. In axiom 6.4, we have studied that if a transversal line intersects any two lines, it is not mandatory that these two lines are parallel. Okay, simply the transversal line intersects any two lines, and if the corresponding angles are equal, right? If the corresponding angles are equal, like this, it is axiom 6.4. Sorry, 6.4. If the corresponding angles are equal, then we can write, yes, this line and this line are parallel. So we can write AB is parallel to CD. This is the axiom number 6.4. Okay. Axiom 6.3 and axiom 6.4 are converse statement of each other. Okay, and today in this lecture we will discuss about a new theorem, that is theorem number 6.3. Okay, so let us first understand the statement of theorem 6.3. So according to the theorem 6.3, it is given that if a transversal line intersects any two lines, it is not mandatory that these two lines are parallel. No, they may or they may not be parallel. Okay, so simply you have to remember that a transversal line PQ intersects any two lines such that a pair of alternate interior angles is equal. So it is given that whenever a transversal line intersects any two lines, then two pair of alternate interior angles are formed, and it is given that these alternate interior angles are equal. Okay, alternate interior angles is equal. Then you have to prove that the two lines are parallel. So we have to prove that this line AB is parallel to the line CD. We have to prove it. Okay, what we have given in the question? It is given that this angle and this angle are equal. These two are alternate interior. Okay, and this angle and this angle are equal. By using this condition, we have to prove that these two lines are parallel. Okay, so let us write first what is given in the statement. So solution. So what is given in the question? It is given that PQ transversal line intersect another two line AB and CD. Okay, so PQ line or PQ transversal line intersects line AB and CD at how many points? At two distinct points, at M and N. Right? And it is given that the pair of alternate interior angles formed are equal. Okay, so this angle and this angle are alternate interior and they are equal. Okay, and it is given that this angle means what? This angle means BMN. BMN is equal to this angle. Okay, for easy identification I have put double line. Okay, so that you can easily identify that these two angles are equal, and single line, these two angles are equal. So this angle is equal to this angle, CNM. Okay, This is one pair of alternate interior angles. Similarly, this angle and this angle are equal. So AMN is equal to this angle DNM. So all these conditions are given in the statement. Now what we have to prove? What we have to prove? We have to prove that these two lines AB and CD are parallel. Okay, so we have to prove AB is parallel to CD. Okay, now we will prove. How we can prove that AB parallel to CD? According to the 6.4 axiom, we know that if we can show that the corresponding angles are equal, then we can say these two lines are parallel. Okay. Similarly, for this theorem, if we can prove that the corresponding angles are equal, then without any doubt we can say yes, this line is parallel to this line. So our main target is to showing that their corresponding angles are equal. Any one pair corresponding angles are equal, then these two lines will be parallel. So our main target is to showing the corresponding angles to be equal. Okay. So see, whenever the line PQ, okay, intersect the line AB at the point M, forget about CD. Then tell me how many angles formed? 4 angles are formed, and 2 pair of angles are known as vertically opposite angles. Yes or no? Yes. And according to the 6.1 theorem, the vertically opposite angles are equal or not? Yes, they are equal. Okay. Suppose this is angle 1, this is angle 2, this is angle 3, and this is angle 4. Okay. Then 2 and 4 are vertically opposite angles. Yes. 1 and 3 are vertically opposite angles. Yes. And they are equal. Okay. So we can write that this angle is equal to this angle, or this angle is equal to this angle. Any one condition we have to write. Okay. Suppose first I write this angle is equal to this angle. Why? Because they are vertically opposite angles. Okay. So write AMN, that means this angle AMN is equal to this angle PMB. What is the reason? Vertically opposite angles. Understood? This is your equation number 1. Right? Next, according to the what is given in the statement? According to the statement, this angle and this angle are also equal. See, angle AMN and angle DNM. These two angles are also equal. Why? Because they are alternate interior angles. So this angle is equal to this angle. Okay. So we can write angle AMN and angle AMN is equal to this angle DNM. These two angles are known as what? Alternate interior angles. And it is given in the statement. Okay, here it is given here, which is given. Understood? You have to mention the reason. Okay. Next, suppose this is equation number 2. Okay. Now we will compare equation 1 and equation 2. Okay. So comparing equation 1 and equation 2. Let us compare. This is your equation 1 and this is equation 2. Now you can see in equation 1 and in equation 2 we have the same LHS. Yes or no? Yes. Here angle AMN, here also angle AMN. If in two equations the left hand side are equal, then we can write that their right hand side must be equal. So we can write the angle PMB of equation 1 is equal to the angle DNM of equation 2, right? So write the angle PMB is equal to the angle DNM. Okay, so what we find? Finally we get the result that the angle PMB, that means this angle, okay, is equal to the angle DNM. DNM, this angle. So these two angles are equal. Finally we get this result. And you can see these two angles are which type of angle? These two angles are corresponding angles. One lies in the exterior, one lies in the interior, and both are on the same side of the transversal line, and they are also non-adjacent. So these two angles are corresponding angles. Okay, but these two angles, or they are corresponding angle. And according to the axiom number 6.4, what we have studied? We have studied that if the corresponding angles are equal, then we can write these two lines are parallel. Here also we get these corresponding angles are equal. Hence, according to axiom 6.4, we can write, what we can write? We can write that the line AB is parallel to the line C. Hence it is proved, and we need to prove this statement AB parallel to CD, and here we proved it. Understood? So here we use the axiom 6.4 to prove these two lines are parallel if any transversal line intersects these two lines such that their alternate interior angles are equal. Okay, so this statement is just the converse or just the opposite statement of theorem 6.2. In theorem 6.2, what we have? We have if the lines are parallel, then alternate interior angles are parallel. Okay, so according to the 6.2 theorem, it is given that if lines parallel, then alternate interior angles are equal. Okay, but here in theorem 6.3, what is given? It is given that if alternate interior angles are equal, then the lines are parallel. So both the theorems are contradictory, are opposite, are converse of each other, right? Hence the theorem 6.3 is also known as converse theorem 6.2. Understood?